Hello and welcome to Introduction to Artificial Intelligence for Humanities. So this course is all about creative machines. So welcome, and I hope you're all going to be excited to take on this journey with me. I believe most of you are from the Humanities course, and maybe there are one or two exchange students, so welcome. I will be your instructor, and let's get started. Okay, before we get on to any introduction, I will talk a little bit about the course organization. So as most of you know already, the lectures will be once a week, which will be on a Wednesday evening from 6 o'clock in the evening to 8:45. So basically it's like two lectures in one go. And there's going to be a break in between the two classes, 7:15 to 7:30. So as most of you know already, the semester this year has changed. So there's it used to be 16 weeks, but now it's only down to 15 weeks. So because of that, there's some kind of a dispute about how we're going to do this midterm. So there will be no midterm or final exam for this course, but there might be a kind of a non-teaching week in the middle. So it really depends on how things pan out. And as you know already, the first 2 weeks will be online. As you can see now, I'm giving you the video. And the first physical class will actually be on Wednesday, March 25th, okay, unless you hear something from school before that. So I will see you on Wednesday, March 25th, and I believe we don't, at the moment of this recording, I don't have a classroom for you just yet, but please be sure to check with school where the classroom is going to be, and I will see you there at 6 p.m. So a little bit about the grading for this course. The assignments and quizzes, so you're going to have assignments as you do with other courses, and they're going to be up to 50% of this course. You will have one final project that I haven't decided whether you're going to work individually or in groups just yet. But even if you're in a group, it's going to be a very small group, maybe just 2 per team. And finally, you will have your attendance is going to be 20% of your grade. So one thing to note about this course, it's going to be evaluated using the relative evaluation. So that means that there's only so many people who can get A's and B's and so on. Okay, so this is one thing that you should note. Another important thing that I want to bring to your attention is I'm actually teaching another course called Introduction to Artificial Intelligence, and that is mainly for data science students, and that is course DSC 3021. Now, that course and this course are fairly similar in terms of content, except that course is rather more technical. It's more designed for technical students. So due to the demand and also due to the fact that the content is going to be quite similar, you should not be signed for both of these courses. So if any of you here are signed up for DSC 3021, which is the other AI course, I would highly recommend that you drop maybe this course and stick to that one if you've already been in it. Or you can come and talk to me and we can decide, you know, what is the best course for you to take. Okay, so this is very important. Another thing is all the slides and assignments, notes, all the communication will be done via the SKKU Canvas platform. As most of you know, we used to use a kind of an old system called iCampus, and this is now like a newer, better version of iCampus. So I have a link given to you there. So if you haven't logged on already, but I assume almost all of you would have done that. And if you have any inquiries, you can email me there. Okay, so normally I would ask you if you have any questions at this point, but I can't, so let's just move on. Let's move on to the aims of the course. So what is this course going to be about? So the main idea is, because it's an introductory course, I want all of you to be able to know what are the concepts of AI. You know, AI is actually very, very hard to define. You know, it is actually a very big field if you know, once you take a bit of this course and try to learn a bit, you'll realize that it's not a small thing. So I want to give you a broad idea of what AI concepts are. What is the meaning of rationality? Because we'll be talking about agents and rationality, and kind of want to know a little bit about all these basic concepts surrounding AI. And then we will look kind of, again, broadly in classical search algorithms. So this might be something that some of you, if you've taken, or if you are taking some kind of introductory to computing course, you might learn some of these search algorithms because they are so important for every computing, and they're also, they lay the foundations for a lot of AI algorithms as well. So those are all very foundation things. And then most people, in fact, all of you and maybe everyone out there, when we talk about AI today we're just talking about something called machine learning. Okay, machine learning is so machine learning is a very, very successful branch of AI, and it is basically what people today think AI is, even though it's a bit broader than that. So because machine learning is the most successful branch of AI, and it is the one that is making waves today, it is the one that is causing all your smart devices and smart applications to work. So we will have a look at machine learning technologies in a very broad sense. I'm going to give you a bit more details about that in the next slide. And two very important things for the humanities students is you need to know about the applications, right? All the different applications that, not all, but as many applications as possible where AI is used, and most importantly about all the ethical implications surrounding AI. So many companies and many countries right now are laying out foundations on how to develop and use AI responsibly and ethically. So these are very important aspects of AI. If you think about it, learning all of this can take a lifetime, right? But we only have 4 months or 15 weeks to be precise. So we're going to have to try to make sure that you get a good balance between some foundations and some application and some ethics, so that when you finish this course, you will have a better understanding, better appreciation, and also maybe if you go on and decide to specialize in AI, you can become a good, responsible AI researcher or developer. Okay, so all the course material will be provided, right? So all the lecture notes will be given. There is a textbook that for those of you who want to read up more, most of the material will be taken from the textbook, but not all. And this is the famous textbook. It's from Russell and Norvig, AI, A Modern Approach, and I've given a link there. And also to let you know, there are copies in the library in Korean, because I've ordered them last year. So if you're very keen on reading more about all these basic concepts on AI and algorithms and so on, you can try to get a hold of this book in the library, which is available both in English and Korean. But the English one, I've given a link. I'm not sure if there is a PDF of the Korean version online. I'll try to find out. Okay, and there's also some basic things about machine learning from Andrew Ng here, which is available for you to read for free. So feel free to use all this course material, because this course will be more about discussion and getting you to think more about AI applications, and you might have to write some essays and so on and so forth. So it's not going to be so easy, but you probably will be reading a lot. I guess humanities students like to read a lot rather than sit down and code. So, okay. So let's look a little bit further. Let's just go through those concepts in a slightly more detail. So all these foundations of AI are going to include concepts such as AI, rationality, and agents. And then we're going to have all these, concepts to do with agents like perceptions, actions, goals, and environment. And we'll then delve into this problem solving and search. So those are going to be, how are problems solved in AI, and how do we go about searching for the solution? And we will start looking at algorithms, actual algorithms, which are like recipes for how problems are solved. And there are going to be several types of search algorithms, like uninformed search algorithms and informed search algorithms. And then when we move on to machine learning, which is sort of the modern AI, which is what all modern AI is about, we're going to look at very important concepts in machine learning, such as supervised learning, unsupervised learning, and of course, deep learning. Okay, so deep learning is an even more specialized form of machine learning, and in fact, today, a lot of successes of AI is actually down to deep learning. Just this one area of AI is, making a lot of things happen today with high performance. So we'll definitely have to look into all of that. We'll definitely, let you know what all this is about. Okay, so then I told you the important part of this course, which differentiates this course a bit from the other course, is you will be looking at applications in more detail. So what are the kind of applications using AI, like robotics, computer vision? Computer vision is just anything to do with images and videos, right? When you are doing your automatic tagging, if you are on Facebook or some of your social media platform, and you will see that the app automatically tags your face, and it also automatically tags your friend's face, right? So all that is actually AI. That's a very big area of AI, computer vision. Natural language processing, anything to do with text, right? When you're speaking to Siri or Bixby or Alexa, right? All that is, it's dealing with text. When you are typing something, you're doing your machine translation, you want to translate something from English to Korean or vice versa. All that is text processing. This is such a huge field. Computer vision and natural language processing are two of the biggest areas of AI. And then we're going to look at kind of more real applications where these techniques are used in healthcare, for example, social media, games, and so many other areas, right? Like self-driving cars. What else can you think about? So many areas is using AI today. And of course, all the ethical and philosophical issues, what are some dilemmas that we might come, what are some problems we can come across when we are using AI systems. We will see how we get on with time, and this is how we will try to divide all these things. But there is a syllabus that I've prepared and you have seen, and that will be more or less what we're going to aim to follow. Okay, so all the admin done and all the course organization done. So let's just get started with what we might, what this AI thing is about. So what do you actually think about when you hear the word AI, right? When you think of the word AI, what do you think about? So do you think some kind of like Terminator robot going around killing people? You think about this, other random robots that are just walking around saying hello to everyone, or you think about more, a humanoid, more like human-like robots. Are you thinking about smartphones? Are you thinking about driverless cars? Are you thinking about drones? Maybe when someone is asked, I remember speaking to someone who is not even in any technical area when I asked them, oh, AI is going to take over the world. And what is AI? Oh, it's all the smart robots running around and ruling the world, okay? So the robot itself is hardware, right? The robot itself has to be built. But the robot, just as a machine, as a whatever, however it looks, it's not AI, right? It's just hardware. But AI is the software, it's the brain of it, what is getting the robot to do the so-called intelligent things. Okay, so smart systems are everywhere, but what is AI? Okay, so let's just look at a quick video.
These are exciting times for artificial intelligence, or AI. But what is AI? AI is the science of making machines smart, using algorithms to allow computers to solve problems which used to be solved only by humans. AI already powers search engines, online shopping recommendations, and digital assistants. Radiologists can use AI to calculate the exact shape and volume of tumors, revolutionizing treatment. Astronomers use AI to find and evaluate exoplanets in distant solar systems. And unhappy motorists are using it to discover if they can overturn parking fines. The possibilities of AI are endless, from fraud prevention to developing new strategies to address climate change. AI technologies today are brilliant at analyzing vast amounts of data to learn to complete a particular task, a technique called machine learning. But AI is not good at transferring what it's learned from one type of task to another. Learning abstract concepts and one-shot learning, where a general rule is learned from a single experience, the sort of broad intelligence humans excel at. But even without achieving this broad intelligence, AI is raising questions. How might AI affect work? People will still be needed in the workplace, but jobs and roles are likely to change as some tasks become automated and new jobs are created. There is a risk that, at least in the short term, this could increase inequality if some people are disproportionately affected and benefits aren't widely shared across society. And what about social equality and fairness? Bias coming from AI systems, even if unintentional, could disproportionately affect some social groups, influencing anything from job prospects to treatment by the justice system. Technology can play a role in helping to manage bias, but people need to address big questions about how society wants to use AI. Technology with AI at its heart has the power to change the world. The more of us that engage with shaping its development, the more chance we have to ensure a better, fairer future with AI.
Okay, so that was just a very quick overview. We will look into that in more detail. So AI was actually coined in 1955. So this is, so it was sort of, people started to look at AI seriously around 1950. That's when it kind of started to come about. So that makes it what, like 70 years, okay? 70 years is roughly when AI has been around. It's very new compared to maybe some of the humanities things you're looking at, like history or mathematics or whatever, language, right? Thousands of years. So it's relatively new, but in technology, 70 years is pretty old, yeah? So John McCarthy, who is this fellow from Stanford, coined AI as the science and engineering of making intelligent machines, okay? Now, so we see the word intelligent. So it's the science and engineering of making a smart machine, because machines, if you think about it, are just silly, right? If you actually make a machine, not silly, I mean, it's just it just does what you tell it to do, right? If it's a calculator, all you say is I add one, put one number, put another number, and put an operator, and it's going to do what I tell it to do, right? It's not going to do anything more by itself. It's just a basic machine. But AI machines are supposed to be intelligent. And what do we mean by that? We mean machines that can think, okay? We might say that this machine should be able to think. More specifically, we might say we want this machine to mimic human behavior, right? We want it to behave like humans, think like humans, because believe it or not, the smartest thing in the world is actually, the smartest system in the world is the human brain. And that is what we want our artificial systems, our machines, to achieve, to have the level of intelligence that the human brain does have, okay? So we want this machine to be able to understand speech, right? If I speak to the machine should be able to understand what I'm saying and what I want. We want this machine to be able to play some games, for example. We want this machine to be like a doctor, a legal advisor, right? We basically want the machine to have the capability of a human being. On top of that, a very important thing that we want the machine to do is we want this machine to be able to learn and create. So this machine is not just, we want it to be a bit like a baby, for example, right? Like it can just learn and explore the world and do something new. So if you think about an infant, a baby that was born, and let's say by the time it's 1 year old, it can walk. But do you see the parents actually telling the baby, okay, from day one, okay, this is how you stand, okay, this is how you walk. No one teaches the baby how to walk, right? The baby is looking around the world, its environment, and it's taking it all in, and it's exploring. If you see a child, it's after some months, it's trying to turn. Then it might turn its body. And then it tries to crawl. It's on all fours. And then it's suddenly starting to stand, and then as it's standing, it's trying to walk. All this is done by itself, right? No one is sitting there telling it, do this is how you walk, this is how you run, right? We humans can do that exploration part. We explore, and we learn, and then therefore we can do something new that we have not done before. And this is also what we want the machine to be able to do. So trying to get a machine to have human capabilities is very ambitious, but this is what AI is about. Okay, we want the machine to be smart enough to be almost like us so that it can help us do the kind of things that we find hard to do ourselves. So what is the true challenge for AI? The true challenge for AI is basically solving tasks that are actually easy for humans to perform, but very hard to describe computationally. So problems that we solve intuitively, right? What is it that we do without even thinking? For example, we can look around and we can know exactly what is around us, right? We know that is a white wall, a brown door, a black screen, and so on, a round clock. We can describe, oh, that's a chair with 4 wheels, and it's gray, and it's ugly. But, we can have so many ways of describing something instantaneously, right? Now, that is not easy for a machine to do. That is very, very, very hard, because machines don't have eyes and brains like we do, right? They only look at images like pixels, pixel values, and then they have to interpret those values, and they have to make some kind of, they have to recognize what is, whether that shape is round or what color that is. That's all very hard for a machine to do. Another thing that's very easy for us to do is speech, right? As I'm speaking to you now, okay, provided that you all know English, you have no problem understanding what I'm saying, right? You're not going to sit there and wonder. If you know the language, you can understand it very easily. You're not, there's no lag. But again, understanding words, if you just give a computer a sentence or a few sentences, even just one sentence, now how is the computer going to understand what that sentence is and what it means? It's actually very, very hard, because it's just a machine. And this is kind of the things that we want AI systems to have. We want it to have the very capabilities that is so easy for us to do, and it's so hard for a machine to do. And this is why AI has always been a hard problem, hard area to work in. And you will see a bit later on that there's some trends of AI from the beginning, and you will see that it has gone through some dips. A lot of times AI was very unpopular and very unsexy to do, and because it was very hard to do these things. But today we're very fortunate. In the last decade, there was a lot of progress made in AI. It just came out of the blue, and AI came up again. So we have to ride with the wave, and we have to kind of go with the flow, because we don't know when AI is going to fall again. It could be soon. It could be just around the corner. Okay, so let's get a little bit more technical about the definitions of AI. So there's been a few ways of how people have tried to define what artificial intelligence is. So if you look in the textbook, these are the 4 different dimensions where people have tried to define what artificial intelligence actually might mean. So there are two dimensions from the point of human and ideal. So we want the system to have some kind of intelligence in comparison to human, and some kind of intelligence with respect to the ideal situation, meaning what is the right thing to do at the right time. And from the dimension of human, we have systems that we want the system to be able to think like a human being. Or we might have the system act like a human. And also in terms of the ideal situation, we want the system to be able to think rationally, to be able to think what are the right things to do, what is the right thing to do at this particular moment. And in the dimension of ideal, we also have acting rationally, meaning it has to do something that is rational. So maybe some of you who study, I don't know, philosophy or some kind of humanities, you might know what rationality actually is. It's about doing the right thing that is morally right, or the best thing. Okay, we will cover rationality in more detail as this soon. Okay, so let's just look at each one of them. So thinking humanly. So when we want to think humanly, we want this machine, sorry, not we, but if we want the machine to think humanly, so we have to know how do humans think, and then we have to try and model all of those, the way that human thinks, maybe, basically we have to understand how the brain works, and there is a field that works on that, and that field is called cognitive science. Okay, so it's also a very big area of research. So there are scientists working on cognitive science. It's about the brain. It's about how we bring AI and psychology to construct precise testable theories of the human mind. Okay, so this is actually another area. You can actually study something called cognitive science. Maybe in Suwon there's a course in cognitive science. I'm not sure, but I don't think we have it on this campus. Okay. The next one, which is very interesting, is acting humanly. So if we want a system to act humanly, this is kind of, okay, how do we then think about the system? If we see a robot and that robot can actually behave like a human being, right? We talk to this robot, we dance with this robot. Robot can do everything like a human does. Then we can say that this system is, comes of special word, is Turing, it passes the Turing test. Okay, so actually this is where this whole AI thing came about. A very, very famous British computer scientist, Alan Turing, he came up with this notion of the Turing test in 1950. Okay, and this is where it all started. This test is supposed to test a system, and if you talk to a system, or if you test a system and you cannot tell apart whether this system is a human or whether it's a machine, then that system has passed the Turing test. Okay? So because he actually gave all the definitions for what intelligence should entail, all the major components that he suggested that a machine that can pass the Turing test will have, he implicitly have come out and said, what are the requirements for AI systems? Okay, so the requirements or the components of an AI system should be about representation, should be about the ability to reason, should be understanding language, and should be about learning. And these are the major components for AI systems, because these are all the components that a system needs in order to pass the Turing test. Okay, so let me show you a quick video on that, about the Turing test.
What is consciousness? Can an artificial machine really think? Does the mind just consist of neurons in the brain, or is there some intangible spark at its core? For many, these have been vital considerations for the future of artificial intelligence. But British computer scientist Alan Turing decided to disregard all these questions in favor of a much simpler one. Can a computer talk like a human? This question led to an idea for measuring artificial intelligence that would famously come to be known as the Turing test. In the 1950 paper, Computing Machinery and Intelligence, Turing proposed the following game. A human judge has a text conversation with unseen players and evaluates their responses. To pass the test, a computer must be able to replace one of the players without substantially changing the results. In other words, a computer would be considered intelligent if its conversation couldn't be easily distinguished from a human's. Turing predicted that by the year 2000, machines with 100 megabytes of memory would be able to easily pass his test. But he may have jumped the gun. Even though today's computers have far more memory than that, few have succeeded, and those that have done well focused more on finding clever ways to fool judges than using overwhelming computing power. Though it was never subjected to a real test, the first program with some claim to success was called ELIZA. With only a fairly short and simple script, it managed to mislead many people by mimicking a psychologist, encouraging them to talk more and reflecting their own questions back at them. Another early script, Perry, took the opposite approach by imitating a paranoid schizophrenic who kept steering the conversation back to his own pre-programmed obsessions. Their success in fooling people highlighted one weakness of the test. Humans regularly attribute intelligence to a whole range of things that are not actually intelligent. Nonetheless, annual competitions like the Loebner Prize have made the test more formal, with judges knowing ahead of time that some of their conversation partners are machines. But while the quality has improved, many chatbot programmers have used similar strategies to Eliza and Perry. 1997's winner, Catherine, could carry on amazingly focused and intelligent conversation, but mostly if the judge wanted to talk about Bill Clinton. And the more recent winner, Eugene Gustman, was given the persona of a 13-year-old Ukrainian boy, so judges interpreted its non sequiturs and awkward grammar as language and culture barriers. Meanwhile, other programs like Cleverbot have taken a different approach by statistically analyzing huge databases of real conversations to determine the best responses. Some also store memories of previous conversations in order to improve over time. But while Cleverbot's individual responses can sound incredibly human, its lack of a consistent personality and inability to deal with brand new topics are a dead giveaway. Who in Turing's day could have predicted that today's computers would be able to pilot spacecraft, perform delicate surgeries, and solve massive equations, but still struggle with the most basic small talk? Human language turns out to be an amazingly complex phenomenon that can't be captured by even the largest dictionary. Chatbots can be baffled by simple pauses like, or questions with no correct answer. And a simple conversational sentence like, I took the juice out of the fridge and gave it to him, but forgot to check the date, requires a wealth of underlying knowledge and intuition to parse. It turns out that simulating a human conversation takes more than just increasing memory and processing power. And as we get closer to Turing's goal, we may have to deal with all those big questions about consciousness after all.
Okay, and I have another video on ELIZA. So that was interesting to tell you about early chatbot systems. And this is actually a very historical one about ELIZA, which was a very first famous chatbot. Now, I will tell you the truth, back in the mid-90s, when I was a new undergraduate students, I have used the system and I've spoken to ELIZA on this, black screen. So this is how famous she was. Let's see a video on ELIZA. Okay, now.
Understand what it's doing in the sense that we do. It's easy to leap to false conclusions, as Professor Weizenbaum discovered when he created ELIZA. Eliza is a computer program that anyone can converse with via the keyboard, and it'll reply on the screen. We've added human speech to make the conversation more clear.
Men are all alike.
In what way?
They're always bugging us about something or other.
Can you think of a specific example?
Well, my boyfriend made me come here.
Your boyfriend made you come here.
He says I'm depressed much of the time.
I'm sorry to hear that you're depressed.
It's true. I am unhappy.
Do you think coming here will help you not to be unhappy?
The computer's replies seem very understanding, but this program is merely triggered by certain phrases to come out with stock responses. Nevertheless, Weizenbaum's secretary fell under the spell of the machine.
And I asked her to my office and sat her down at the keyboard, and then she began to type. And of course, I looked over her shoulder to make sure that everything was operating properly. After 2 or 3 interchanges with the machine, she turned to me and she said, "Would you mind leaving the room, please?"
And yet she knew, as Weizenbaum did, that Eliza didn't understand a single word that was being typed into it.
You're like my father in some ways. You don't argue with me.
Why do you think I don't argue with you?
You're afraid of me.
Does it please you to think I'm afraid of you?
My father's afraid of everybody. My father's afraid of everybody.
Okay, so that was, I hope you enjoyed that, that thing about Eliza. So as you can see, it dates back to 1966. These are like very early stage AI systems, right? We've come a long way now compared to your smartphone and Siri and Alexa, but this is where it all came from, okay? So that is about acting humanly. Thinking rationally is kind of a little bit more about getting systems to think and do the right thing. So this is something like logic-based system. You can give it like a bunch of rules, yeah, and say, if something happens, you know, if this something happens, then you do something else. So you give a bunch of rules, and you want systems. A lot of early systems were displaying this, right? Like it's a slightly, if you like, simpler version of the acting humanly just now. So a lot of systems, early systems, were systems that were logic-based, because you just give a set of rules, and all the system has to match all those rules, and then you can make sure your system is clean and it does what you expect it to do, right? So, however, there was some shortfalls with this system. So firstly, if you want to state about a particular world or particular domain you're working in, it's quite impossible to define every rule that's going to define that world, right? Which, I mean, this is maybe not easy for someone like you without a computational background to imagine, but when we do things in the computing world, we have to start from the beginning without any background. So we have to describe everything, every single thing from scratch. And this can be quite hard. And sometimes it's hard using logic. I'm not sure if we will look into logic in this course. We may not, but the other course does. So the formalism for logic-based systems are a bit restrictive. And that is one problem with logic-based systems. Sometimes it's very hard to describe or to formally describe certain things, like temporal things, or the field of logic actually is a very big field. Again, some of you who may have studied mathematics or philosophy might have come across logic, and you might know what I'm talking about. Okay, and this can also be computationally exhaustive because there are just way too many rules. Okay, so which brings us to the final dimension, which is acting rationally. And this is where we are going to be giving a big focus in this course, but also almost all AI systems are, many AI systems are trying to do this. Of course, the chatbots and all of those kind of systems are trying to go for the acting humanly part, right? But this is, in fact, almost no system has passed the Turing test today. Okay, you can imagine that. So it's quite hard, but people are working on it. So in the field of acting rationally, rational behavior is what we say doing the right thing, which is that which is expected to maximize the goal achievement given the available information. So for example, all of you are students right now, yeah? Okay, let's just say, for example, you're all data science students. You might say that one day, you will graduate and you want to be a respectable data scientist, right? That might be your goal. So, as an agent, as a rational agent, what should you be doing right now so that you can maximize your chances of being a respectable data scientist? You probably, number one, want to do a bunch of data science courses that are related to what you want to achieve. If you want to be a data scientist, probably you want to do courses in the data science school and not do something else like dancing or fencing or, economics, right? So you have to do the actions or the things that are going to get you and increase the chances of you being a respectable data scientist. Maybe, and you know that maybe the field of data science is quite difficult, quite new, and a lot of things are changing, so that means you might be expected to learn new things from time to time. So you might want to attend forums, you might want to take classes online, you might want to sit for this course, right? You might want to be doing things that is going to help you gear towards that, instead of saying, oh, I'm going to spend a whole year doing, French. And then you go, okay, but if that is the course of action you're going to take, then your goal of trying to be a respectable data scientist is probably not going to be maximized anymore, right? Because it sounds very simple and intuitive, but that's kind of what it is, okay? So you have a goal, and a rational agent is going to do the right thing towards that goal. So for example, you have 3 more weeks to an AI exam or a very difficult exam. So what is the rational thing to do? The rational thing to do would be to spend so many number of hours every day or every week in the library studying for that exam. What is an irrational thing to do? The irrational things to do would be to procrastinate and hang out with your friends and go to the cafe and go to the bar and whatnot, go to the movies, okay? So that is what differentiates a rational agent from a non-rational agent. And this is why we had to distinguish between rational agents and human beings, okay? Because human beings can be awfully irrational, right? So if you are going to have an exam in 3 weeks, what are the chances, is there a chance that some of you are going to be hanging out with your friends and going to the movies? I think the chances are quite high because I was one of those students too. I did not want to sit down and study for my exams from early on, right? Because I was not being a rational agent. I was just being an irrational human being. So this is where we have to balance between making the system human and making the system rational. And rational is very important in the development of AI systems today because we are talking about ethics as well, right? A human being might have murdered someone, okay? Not everyone goes around murdering people, but there might be a chance that there is a person who murdered someone. Now, if you build an AI system and that AI system goes and murders someone, what happens then, right? So that is not a rational behavior, right? Murdering someone is not rational from the point of view. So this is why we need to differentiate between being humans and being rational. And I think now some of you may start thinking, oh, so there's this big gray area. What is the kind of systems you want to build now? Exactly. You know what? All these things have not been resolved properly in the world today. That's why a lot of people are still talking about ethics in AI. How do we build systems that are, how do we judge these systems? What if the system does something out of something irrational? Is that okay? If it's a human being, we can try that person, we can send that person to jail, but what should we do with these systems? Okay, so that's why we want to limit the scope for now, and all the systems are just trying to be rational. It's going to try and do the right thing. Not just necessarily what any human might do, right? All of us may have been irrational at some point in our lives, or more than one point in our lives, maybe every day, right? So it's all very interesting. So the rational agent is one that acts so as to achieve the best outcome, or when in uncertainty, the best expected outcome. Okay, more on this, okay, as we look further in the agent lecture next time. And this is where we are going to concentrate our course on, building rational agents. Okay, so just to have a quick pause, you've heard a little bit about AI definitions and so on, okay? And so think about, I want you to take a few minutes now to think about what are the things that you think computers can do well or easily, but humans find hard to do. And also think about the things that humans can do well or easily, but computers find hard to do. So you can pause this video, think about it, take a couple of minutes to think about it, and then we'll come back and discuss it. Okay, so I hope you have had a few minutes, you have paused the video, and you have tried to think about what are the things that computers can do well, and what are the kind of things that humans find hard to do. So when you think about these things, what are the things that computers can do well? Computers can do computations very, very well. Anything that is mundane, anything that is repetitive. Think about like a pizza factory, right? Where you kind of have to make the dough of the pizza, and you have dough, 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 put the dough, put the dough, put the dough, and then put the topping, you know, put the sauce, put the sauce, put the sauce, put the sauce, put the meat, you know, put the topping, you know, and so those kind of things, if you get a human being to do that in a factory, like, okay, I'm putting the dough, I'm putting the dough, I'm putting the dough, right? That kind of stuff is very, very, I mean, it's not impossible, but we are prone to make errors when we do that, those kind of things, yeah? So computers can do those kind of things that are very repetitive, manually, you know, laborious. They can do computations very well, right? Addition, all the multiplication, you know, big numbers added by big numbers, lots of matrix manipulations, those kind of things like numbers. I mean, you do have some genius people who are geniuses who can do that kind of stuff, but not to the ability of a computer, right? It can do number crunching very well, yeah? Those are the kind of things computer can do, but humans find hard to do. Now, on the other hand, what are the things that humans can do very well, but computers find hard to do? Okay, we already mentioned a few of these a little bit earlier on. What are the things we can see, for example? We can do all this vision task, right? Even a child who is maybe 3 or 4 years old can look at something and say, hey, that is a black cat jumping over the wall, right? A little child might be able to say that, might be able to look at this environment and say that. Now, even until today, for a computer to say that takes a lot of learning. It's not easy for a computer to just look at an image or a video of a cat and doing that and saying a black cat is jumping over the wall. I mean, state-of-the-art systems can do that, okay? The highest computer can do that. So this is where we have to see that a human being can do vision, all the image processing tasks very easily, right? That's a black chair, that's a green coat, you know, that person is tall, you know, that is a red flower. Yeah, we can do all of these things easily. We can even take it, you know, further. That mountain is 3 times further than that building. What else can we do easily? We can do speech recognition, natural language understanding very easily. If I'm talking to you, you can listen to me and understand me immediately, and you can even answer my question, and you can give your argument, and we can have a debate this all happens in no time. This is very hard. These are very challenging tasks for a machine to do, because a machine only sees bits and bobs. It only sees like little numbers coming in, and it has to make sense of it. It doesn't have a brain, the special brain that we have. What else? Walking, right? Things like walking. So easy for us to do. If you want to get a robot to walk, it's not easy. Robot walking is not easy because it has to know where it is, right? Building an actual robot is so challenging because it first has to know where it is, whether it's going to hit something, if it goes front or back, right? Whether there's a wall on the left or the right. So building a robot and getting it to do things like walking is really, really hard. So more on this, I guess, as we go along. But you always should be thinking about these things so that you can tie back and you can understand and appreciate why people are so much talking about, what's all that hype about AI? Because guess what? Computers are doing these things today, right? You are talking to Bixby and Alexa and Siri like no one's business, but actually those things are very hard for a computer to do, to understand what you're saying. But you will just say, hey Siri, call my cousin right now, and Siri will do it for you. Right? You think that Siri is really listening, is really alive and listening and understands. It's so hard. It's actually very hard, but state-of-the-art systems can do that. And this is what makes them really special. And this is why everyone is talking about AI, and everyone is excited about AI, and everyone is scared about AI too, okay? Okay. Okay, so let's just have a quick look at what AI, where AI actually came from, right? What are all the different fields? So right now, AI is kind of becoming a field in its own right. I mean, it is a field in its own right. Almost every university now is teaching AI, right? But that was not the case, 20 years ago, even when I was an undergraduate, it was not necessarily the case. AI came about from so many different fields. Look at all these different things, and maybe there's more. Okay, so things like logic, logical way of thinking, rationality, all this comes from philosophy. So philosophy has existed forever, right? From Aristotle and Socrates and all this amazing things. Maybe some of you here are philosophers, okay? I'd love to hear from you more. And mathematics, of course, you need mathematics for any kind of computation. Okay, mathematics is actually used in almost any technical field. You need mathematics. Psychology, so this has got to do with the brain and the cognitive psychology. Economics, so things like expert systems. Expert systems are basically your knowledge-based systems. Decision theory, game theory, even economics has influenced AI, and of course we can't deny the fact that linguistics is a big part of AI. We just spoke about natural language processing, what natural language processing is all about, understanding speech, even how we represent computer languages. They're all from linguistics, very huge field. Maybe some of you are linguists also, hats off to you. It's not an easy field. And then you've got neuroscience, so this is the brain science again. As you know, neural networks is deep learning, which is, I told you, the fanciest AI technology today. And neural networks is just modeled after the brain. It's trying to be the brain, the human brain, really. It's all very interesting. So that's neuroscience. And of course, you've got computer engineering, which is like a field on its own, and all the hardware and everything that comes with it. And also you've got control theory and cybernetics. But this is just a history. But I think today AI is impacting so many other fields. AI is used in almost every area. Everybody wants to use AI, right? But this is kind of where AI got its ideas. And then Alan Turing, came up with all these ideas for how do we think about whether this machine can behave like human, and came up with the Turing test. And this was a very big foundation for AI. Okay, so if we look at some timeline, an important timeline, okay, we're not going to start from 1642. Someone called Charles Babbage, he was also like the father of computing, and Ada Lovelace, she's someone who brought about programming. So these kind of pioneers were already there, a couple of centuries ago. But the real, there's been a lot. I think if you do things like history and philosophy, you might learn a little bit about all this. The real point came here in 1950 when Alan Turing introduces the Turing test, right? That was sort of when it first got sparked and got excited, got people excited. Isn't that cool? Oh, if we can get a machine to behave like human, that is so, so, so cool. Back in the 50s, remember, that's when it happened. And so there were that sparked a lot of interest. Now, Alan Turing was an amazing human being. He was also involved in the Second World War. When the British were against the German, and he was using his intelligence to decipher the code from the German side. Okay, so you can look up all about him if you want. The only thing I haven't done is I haven't visited Bletchley Park, where it has all the Enigma machine and everything. Okay, so if you have a chance, do it. You can watch the movie about him, which I've included the link at the end. And we've got AI becoming an actual word. The term was coined then in 1955. And then you've got all these systems coming up in the 60s, the early enthusiasm, ELIZA, chatbots. Imagine none of this existed. Think about your parents. Think about your grandparents. If they know, But back in the 60s, there was ELIZA, the chatbot, who was obviously making waves. Imagine you could talk to a psychotherapist, or you think you're talking to a psychotherapist, but here is a machine that you can talk to all day long, and so there was a lot of early hype, and then what they realized was it was very, very, very hard to actually come up with a system that was truly smart like humans. And there was a lot of failure in that moment, especially in the 70s. And that's when AI kind of went on a dip or on a winter, so we say, around the 70s. And then there were the rise of expert systems. Expert systems were like those knowledge-based systems I was talking about, the logic-based system. So people like NASA, they were coming up. They used AI systems. There was all this kind of systems that were around using rules and knowledge base, and that was the de facto AI systems. And I think robots were starting to come, but it was so far away. And guess what? We are still far away. We are still far, but we have some concrete things going on right now, right? And then there was another kind of winter in the 90s for AI. That's when I was doing my undergraduate, and I was very fascinated by AI at that time. But it was not such a big deal at that time. No one cared about neural networks. It was just one other technique. So it's funny, right? It's funny you don't know what you're doing now could be fancy another time. And then in 1997, IBM came up with Deep Blue, which beat the world famous chess player at that time. So that was huge news. And that was, I believe that was like an expert system. I think it was mostly a logic-based system because machine learning was already around, but like I said, it wasn't making progress. It wasn't making progress because it wasn't getting the performance it was supposed to get, right? The models were there, neural networks were there, the models were there, but getting them to work in reality was hard because firstly, there was not a lot of data lying around, and secondly, the machines were not that powerful. So for these kind of complex models to work properly, you're going to need very fast machines with very high capabilities, and you're going to need a lot of data. And all this was missing back in the 70s, 80s, and 90s. So machine learning couldn't really, people were trying because people could see that if you could get all this to work, you're going to get a very powerful system, a smart system. But it wasn't happening. So the only thing was still Deep Blue, which was still very much like a logic-based system, but it gave AI a little bit of a revival again, right? So it was kind of coming around, and machine learning in the 90s and noughties was an area that was starting to gain momentum. And yeah, so machine learning was the new thing that started to make some progress, and at this point computers started to get a bit more powerful, a bit faster. You got better memory, better processing speed, and machine learning started to make some progress. And the biggest achievement came in 2016 when AlphaGo, which was a system developed by DeepMind, a subsidiary of Google, which uses reinforcement learning, which is a kind of learning, with deep learning. And that system was able to beat, maybe some of you should remember Isedo, who is the best Go player in the world. So this was a huge comeback, right? AI came back with a real bang, okay? But this was neural networks, because by now we have GPUs, we had very high processing units available, and therefore the promise that machine learning neural networks could work was a reality, and there was a lot of data today. No problem with data with the social media and internet. There was data everywhere, and that allowed machine learning to come back with a big bang. And there was more progress made. Oh, okay, I kind of missed all of this here. Okay, but roughly that's what it is. And another important one was around 2007, the iPhone came out, right? Steve Jobs announced iPhone, the first smartphone. Now that got everybody crazy. 2007, everybody, at least in the US, they were very, very excited. And then it was all about smartphones. And smartphones needed smart technology because it had to do natural language processing. It needs to be able to recognize your face and things and all that. So, and this is the era where we're living in, where you're living in. You're really fortunate to be at this moment in time where technology is making huge leaps and bounds, where for decades there was a lot of slow progress. But there is some talk in 2020 now that deep learning was such a big deal in the past 10 years, and everyone was talking about it. And now there is some signs that it might be going to an autumn phase. Not quite winter yet, but a kind of autumn phase, because they're a little bit sick of this whole, getting these neural networks to work, and we've been there, done that, but we still cannot explain how we got there, because neural networks are just like black box models. There's still a lot we cannot interpret what has happened inside that neural net. Why has, the result, why has this system predicted that this is a cancerous cell? So the system doesn't know anything about medicine, doesn't know anything about cancer. And if you want to convince the doctor or convince, a domain expert that you want to trust this model, then you must be able to explain how that model came to that result. And this is still, this is the kind of, there are several limitations of these systems. And so people are now trying to work more on interpreting and evaluating and giving explainable concepts. And this area called explainable AI is, kind of an active field right now. People are trying to find ways to explain how these AI systems work and get where they are. Okay, so this is just like I've already spoken about a lot of this. 55, and you see this kind of dips here? There were like 2 big winters there. I don't know if this is going to go down here again, okay? Maybe we'll know. All this enthusiasm at the start, slow progress, expert systems, and big data and deep learning. So big data and powerful computers both were the fuel for getting neural networks to work successfully. Okay, and a few major areas of AI. Now, I spoke a little bit about machine learning. We're going to cover this as the lecture progresses, because it's a very big field. Machine learning is used in all of these other fields, okay? So machine learning is used in natural language processing. Machine learning is used in vision. Machine learning is used in speech. Machine learning is used in planning and robotics. We also have expert systems, which are the logic-based systems, and those are the earlier AI systems that we saw, pre-1990s, even in the 1990s. But after the 2000s, a lot of the systems were more on machine learning, and especially now, that is what successful AI systems are. But that doesn't mean that that's all. There are so many techniques in AI that can achieve, trying to achieve human intelligence or rational intelligence and so on. So you never know. This technology might just be shelved, and then another technology comes in, and that's how technology is, okay? So what are the state of the art? What are the kind of things that, we are all living today and experiencing and using successfully? Computer vision, okay? Anything to do with video recognition, image recognition, automatic face tagging, robotics. Robotics is still very hard, and it's very hard to achieve, but it is a field in its own right, and there are some very big robotics labs that are working on this. It's very ambitious. So normally the kind of robots you really get now are just like a robot arm maybe, because it can just go there, grasp something, pick it up, and that's already a big feat, okay? Because it's very complex. Getting a robot arm to do that is complicated enough, but you see, this is why I say we're still a long way to go. We still have a long way to go, but we're trying to get there. Games, okay, so games, as you saw, there was AlphaGo chess, there's also StarCraft, there's all kinds of new AI systems working on games. So the thing about games is, it's interesting because if you, I think, play StarCraft or whatever one of this now, and if you're playing against the system, the AI system, it's going to be very hard for you to beat that system because it is an AI-powered system, which probably can beat you. Well, I'm not really playing a lot of AI games, but maybe you are. You can attest to that. Machine translation, of course, if you're translating languages, this is a very big part, and it's used every day. As we saw just now, those videos on YouTube, and I had the subtitles at the bottom, and that was automatically generated by Google. So that was AI. Medical imaging, this is where AI is really trying to get serious. It's trying to get into, to making a difference to humanity, right? What's the point if AI can be a great game player? I mean, yeah, that's fun, but that's not really going to bring, humanity forward. What we want AI to do is we want it to work on things like the medical field, okay? We're going to look on the COVID case study, and that will give you a little bit of better idea. Speech processing, of course, if you're talking to your digital assistants, Siri, Alexa, and so on, Bixby. So what are some of the actual applications? So product recommendation, right? When you go on YouTube or when you go on Naver, when you are trying to go shopping on Coupang or whatever, you will see that the music that you like, the kind of music that you've been listening to will appear. It will start showing videos of the kind of music you've been listening to. Maybe it's K-pop, maybe it's jazz, I don't know. If you're listening to lots of this, it will give you this recommendation. Now that is AI. That is very much AI, a very common thing about AI. If you go on your shopping website, you're going to see, if you like baseball and you've been buying a lot of baseball products, you're going to see it recommending more and more baseball products, right? You do know that, right? Like your sister or your brother who might be interested in something else, when they log on to the system, they will get different recommendations. They're not going to get what you get. It's very personalized. Predictive maintenance, how do you maintain products and see whether they fail, whether we can catch the failure before it happens. Fraud detection, credit card fraud detection, email spam filters, chatbots, self-driving cars, digital assistants, okay? Those are all very common applications. You're probably using them every day. And according to Accenture, with this big company, 77% of smart devices include at least one AI feature. So that means almost everything we use, 77% of any smart device that you call has at least one AI feature. Okay? So what can AI do today? I don't know if I want to show this video. There's another video for you.
Robot overlords. Sentient computers.
I'm sorry, Dave. I'm afraid I can't do that.
Armageddon. This is what many people fear when artificial intelligence, or AI, comes to mind.
I'm Martin Hitch, and I'm the Chief Business Officer at Bossa Nova Robotics. I think AI is misunderstood. We have this expectation that it's going to take over. And the reality is, we're many, many, many years away from AI being sentient.
Instead, what we are seeing today are devices like Amazon's Alexa, Google's Home, or Apple's Siri. These gadgets may sound sentient.
It's 61 degrees Fahrenheit with mostly sunny skies.
But really, they're far from it.
Hi, I'm Robert Munro, and I'm the CTO of Figure 8. The AIs that we're building are AIs that we can smartly interact with. So they're not optimized to be independently intelligent. They're optimized to be our guides, our assistants, the extensions of our memory.
Aside from consumer electronics, artificial intelligence's greatest promise may be in transforming entire industries. The underlying technology making this happen is known in the tech community as supervised learning.
You have humans who are able to provide the training data for algorithms to then automate a task. So for example, a self-driving car knows how to avoid a pedestrian, knows how to stay in the lane, because humans have sat down with images taken from the front of these cars and said, this is a human, this is the lane which marks the edge of the road. And it's these thousands and thousands of hours of human feedback which ultimately enables a self-driving car to be trained to automate this task.
Google's Waymo is on the forefront of self-driving car technology and is using supervised learning to drive it forward. But in fact, transportation is just one area that is booming in the field of artificial intelligence. Another is healthcare.
I am Fabian Beckers, CEO and co-founder of Arteries.
Meet Arteries. Their machines have been trained on thousands of patient images, which gives physicians and radiologists better information for diagnosing cancer in the brain and lungs, and also detecting dangerous heart conditions.
A radiologist normally has to be highly trained to really look at the organ. Spend a lot of time sometimes just drawing contours by hand, like the ventricles or the atrium. And that takes a lot of time. And so what we have been working on is automating that and automating well. We train the system on thousands of images where we know exactly what the answer is. There's a really quantum leap because the system can really propose a suggestion to the physician that's probably very close to what he or she would have done.
Agriculture is also seeing a big change in the use of artificial intelligence.
I'm Jorge Herod. I'm the CEO of Blue River Technology.
This is Blue River Technology's See and Spray machine. Using artificial intelligence, the robot is able to detect which plant is a weed and which is a crop.
This is one of our 12-row machines. It goes through the field very fast. It's a very wide machine. And back there, there's a camera that is looking down at the ground. It looks at every single plant 50 times per second. Every camera that it has is looking at every plant and deciding, is this a crop, is this a weed, and applying herbicides only to the weed and nowhere else. And by doing that, we can reduce about 95% of the herbicides being used. We have a database that is growing really fast. Now it's close to 1 million images that we've collected across many different farms, many different geographies. That gives us the variability that these algorithms need in order to be trained and reliably detect which ones are weeds and which ones are crops.
From farming to the food that you shop for, AI is impacting the whole supply chain. At Bossa Nova Robotics, robots scan the aisles of the supermarket, aiding retailers in logging grocery inventory.
They're robots that are designed to move autonomously through a store, taking very high-resolution pictures of the shelves, and we then use a very complex AI engine that extracts data from those shelves. So think about product data, labeled data, the layout of of items on the shelf. Are they in stock? Are they out of stock? All that information happens in near real time.
The robots use computer vision to see the store shelves and are trained on thousands of images to complete their task.
You can imagine now you're starting to gather a very, very large data set of products. We use that to train AI algorithms to identify specific features. If we're successful, we blend into the background and your shopping trip means you buy 100% of the items on your shopping list instead of 80% of them.
Of course, robots that can roam the aisles at the supermarket or tractors that can automatically graze crops is just the beginning. Experts believe a profound technological shift is underway.
Okay, so I hope you enjoyed that video. So let's see what AI can do today. Firstly, I want you to have a look at these tasks and think about what are the kind of things that AI can actually achieve today. Okay, so let's look at the first one. Play a decent game of Go. So Go, as we already mentioned, maybe like decent game of chess. So this is something that, yes, AI is able to do today. And number two, this next one, drive safely along the streets of Seoul. So autonomous vehicles is something that we can see right now, but in terms of performance, they are getting there, but actually they are still far away in terms of maybe they can walk on, maybe they cannot, sorry, they can drive on a nice controlled environment, yeah, with not major traffic. But I think driving in like, a busy street in Seoul, in Jongno area or in Gangnam, it might not be able, it's probably not there yet, right? So we're not exactly there yet with number two, okay, but there's a lot of work on it. Maybe this box will be ticked, in 6 months' time or a year. Okay, next one, write a review for an online product. So among the many things AI can do, AI can also generate things. It can generate images, it can generate text. AI can do those kind of things as well right now. And believe it or not, AI can write a review for an online product. So when you are in Coupang or Gmarket, when you are reading these reviews from customers, beware that maybe some of those reviews are not real. In fact, there's some stat right now about chatbots or artificial agents are making up some significant percentage of internet traffic. So internet traffic is not just made by humans, but also artificial things. Yeah. So now we have to compete with some of these things. Okay, next one. Perform a complex surgery. Now, have any of you heard about this robot-assisted surgeries? We have them, and in fact, in Korea, which is fairly advanced, has robot-assisted surgeries. Now, why do we have robot-assisted surgeries, right? Because humans may not be able to do very minute, go to areas and do a very subtle kind of surgery that our fingers and a surgeon, even the best surgeon, may not be able to perform. But if you have this kind of tiny robot, very small robot that's able to navigate in and perform that surgery, it's very possible. So now, these robots that actually do the complex surgeries are not working alone. They are actually just being instructed by the surgeon. Okay, so the human is very much in control here. It's just the robot is able to do the delicate task of, doing a very delicate surgery that, humans may not be able to do with high precision. So performing a complex surgery, yes, AI can do that now, and this is a very helpful area. Next one, converse with someone for a full hour. Okay, so we saw that Eliza was talking to someone. So can you have a conversation with a chatbot for a full hour and have a meaningful conversation? Okay, so this is kind of interesting because it depends on the person. I have my 5-year-old niece the other day who, whenever she sees me using my laptop, she comes and she starts talking to Siri, and she goes, "Hi Siri," and then she starts talking to Siri, and because she's a child, she's just asking all these childish questions to Siri, and after a while, Siri is just not even, Siri just says, "Oh, I'm sorry, I didn't get that. I didn't quite get that. Can I help you in another way?" So having a meaningful conversation, even for a 5-year-old, she knows very quickly that she's not talking to a human being. So this is still where, if a chatbot can actually fool you into thinking that it's a human, then it's past the Turing test. And as we said, it's very difficult for any system to pass the Turing test today. But some people are claiming, Sophia, some people are claiming these robots are passing this Turing test. But there's a lot of uncertainty exactly how this system work. They are not fully like humans. They have some erratic behavior somewhere. So that's not actually possible yet, but of course it depends on the person. Maybe that person might be able to converse with a chatbot for a whole hour and think it's a normal conversation. I would recommend that you talk to your, to your phone and see how long you can get by, how long you can have this conversation and how far you get. And the last one, translate spoken English into spoken Korean in real time. So let's have a system, so this is spoken. As for the systems we saw just now, the automatic translation that we saw on YouTube, that was already done beforehand. Oh, but that was actually done by humans, I think we saw that. But some of auto-generated were not done in real time. They were done before and then they were put on there, okay? So imagine you're in a conference right now, or imagine you're listening to me right now, and then you get an automatic translation with a voice on it. This is actually still not possible. If you go to conferences and you're wearing that earpiece to get a translation between different languages, that's actually done by an interpreter, a human interpreter. So this is also a very active area of research. I mean, there are systems that are trying to do that, but in terms of performance, they are not really quite there yet. Okay, so this is just to give you a very rough idea. Maybe there are other tasks that you are also thinking about where AI is right now. Okay, we won't actually cover this in much detail right now. So there's 2 types of AI. Some people believe that, many people believe that, AI machines could act as if they were intelligent. So, if Siri can help you, make a phone call, Google Translate can translate, your Korean to English. So those machines are kind of acting as if they were intelligent, but they're not actually really intelligent. Machines don't know languages. And this is kind of what a lot of people, or that's the assumption that we make, right? AI was founded on the assumption that weak AI is possible. But strong AI, on the other hand, we're talking about machines that can really think and can really do very, very challenging tasks, like really behaving like a human being. If you like that Turing test, a proper chatbot that passes the Turing test, right? A self-driving car, if it can work in a real sense. Those are like strong AI. We're saying that the machine, some people say have consciousness. It's something of a real entity. So this is a topic for debate, really. And I've added some interesting links for you. So if you want, you can read more about all that definitions in the first chapter. If you really want to read Alan Turing's paper, that's from 1950. I haven't read it, but I'm sure it's a good read. And also, I've mentioned the movie, The Imitation Game, is all about Alan Turing, if you're interested. So, okay, so that kind of concludes the current topic of AI, but I'm going to move very quickly. I'm going to move on to a case study now on a very interesting topic, so that you get an even better idea of what AI is, and that will give you something to work with the next time we come back and we learn about agents. So, okay, so in the second part of the lecture, I'm actually going to talk to you about AI helping in the COVID outbreak. So this is very new stuff and very exciting. Let's do a quick recap. So I kind of told you what were the major areas of AI. So these are the major areas of AI, like natural language processing, computer vision, speech, planning, and robotics. I didn't mention much about planning, but we will work through it as we see today. And machine learning is just a technology that is used in a lot of these areas. Yeah. So what I want you to do is I'm going to give you a small exercise. I'll give you a series of videos to watch on the COVID side, and then I'm going to ask you to think about which are these areas that the AI system or the AI component is trying to tackle. Okay, so a very quick overview of COVID-19. COVID-19 is a novel coronavirus disease. It's a type of viral pneumonia with flu-like symptoms, as I guess all of you know right now, as you are any part of the world, but especially here in Korea. And it originated in Wuhan in China in 2019, but it has spread to over 23 countries since its official outbreak in January. But the truth was it kind of came out in December. And it's very similar to SARS, which came out in 2003, and MERS, and these are like very similar kinds of viruses, this coronaviruses. And at the moment, it has affected over 80,000 people and has caused over 2,700 deaths and counting. Every day it's going up. So I hope everyone is taking good care right now. So I won't talk more about the actual background because I'm not an expert in this area. But what is interesting and what caught my eye is AI is really trying to help with this kind of areas, and I've just kind of found a few areas where AI has been helping. Okay, so we're going to look at a series of videos on how AI has been used or been trying to be used to tackle this problem. Okay, so the first one is, we don't have, the first one is about robots, so let's have a look.
您的物品在第1层，请取走您的物品，为避免交叉感染，请勿触碰机器人。祝您身体早日康复，我要去忙了。
我
倒几次，倒几次。慢一点，慢一点，不着急。啊，可以先放，没事没事。
主人，您的美食到了，请拿好您的餐盘，快点击完成哦。客官，请您慢用，我要去拿啦。310号桌客人，您的菜在第2层托盘，请取餐，并点击完成哦。
Okay, so as you're watching these videos, I want you to think about what kind of AI components, okay, which I showed you just now, like robotics, image processing, natural language processing, and whatnot, is being used. Okay, so here's another part where
机器人会根据这个空间的大小，自动的计算出我需要的照度指令，然后机器人还会通过各种各样的传感器检测这个环境中是不是有人。如果有人，它需要把对人有害的消灭方式能够关掉，并且语音提醒他离开。
我是防府公安巡逻机器人，警方提示，请大家戴好口罩，注意个人卫生，不要前往人流密集场所。身体若有不适，请及时就医。
两位大妈，请戴上你们的口罩，赶紧回家，赶紧回家！别看了，大妈，说的就是你呀！把口罩戴上，赶紧回家，赶紧回家！
有了这个体温检测系统以后，我们不用对旅客进行近距离的接触了，对我们自身也是一种保护。
Yeah, that's really interesting. And then we have something about temperature screening. And then it's also used in early outbreak predictions. Let's look at this.
Coronavirus. You've probably heard of it by now, but did you know that an AI system predicted the outbreak way back in December? Today we're going to talk about how a company used machine learning to anticipate the Wuhan outbreak way before it became a massive public health concern, and how they continue to use AI to track the outbreak as it spreads. If you're new here, say hi and let me know how you found my channel in the comments. And if you like this video, you can let me know by giving it a thumbs up and subscribing to my channel so that you can stay on top of how you interact with AI on a daily basis. In early January, the World Health Organization and the US Centers for Disease Control and Prevention announced to the public that a flu-like illness had begun to spread through a city in China called Wuhan. And in the months since then, fears of a coronavirus pandemic have spread faster than the disease itself. But the WHO and the CDC weren't the first people to figure out that something was spreading through Wuhan. Blue Dot, a Canadian health monitoring company, had predicted the outbreak way back in late December, going so far as to warn their investors not to visit the area. How did they do it? Well, the developers at Blue Dot developed an AI system that took in news reports in 65 different languages, as well as airline records and reports of animal disease outbreaks to predict when new outbreaks would occur and track existing ones. The system's predictions were then validated by scientists, epidemiologists who had been trained to make sure that these predictions made sense scientifically. If the scientists thought that the predictions were valid, then they would create a report explaining what the outbreak might be and where they'd expect it to start, and send that report to public health officials, airlines, and hospitals that either may already have patients with this disease or may be soon receiving them. Blue Dot systems can also track outbreaks, predicting where they might spread next. In fact, the system correctly predicted that the coronavirus would spread from Wuhan to Bangkok, Taipei, Seoul, and Tokyo in the days immediately following its initial appearance. Something that I found particularly interesting is that Blue Dot does not use social media posts to track outbreaks. You might think that tracking things like Facebook and Twitter would give you a better idea of who's talking about feeling sick and when, as well as where, but they found that data to actually be too unreliable to use. This also isn't the first time that Blue Dot has correctly predicted an outbreak. They also correctly predicted the location of a Zika virus outbreak in South Florida in 2016, and the results were published in The Lancet, a major medical journal. So why don't we use AI systems like this all the time? Well, epidemiologists have been performing this work for decades, so the system, so to speak, has been around for a while. Epidemiologists might look at anything from statistics on the geographic distribution of a disease to the demographics of the people who have it to figure out where it originated and where it might spread next. This can be a lot of data to sort through, though, so the benefit of using AI is that these systems can sort through this information much faster than a human ever could. Additionally, we have actually tried to use AI to predict outbreaks before. Google developed Google Flu Trends in an effort to predict the severity of the upcoming flu season. Now, as we've talked about in another video on my channel, researchers have used AI to create a more effective flu vaccine by predicting how the virus would mutate in the future. Unfortunately, however, Google Flu Trends was not effective. They underestimated the severity of the 2013 flu season by 140%, and the project was quickly scrapped afterwards. And this failure may have led other developers who were interested in outbreak prediction to shy away from this challenge. Personally, I'm really looking forward to seeing more AI systems applied to the challenge of disease prevention and tracking. However, it's important to realize that as helpful as AI might be in these scenarios, this information isn't available to the public, and so we still have to rely on public health officials to share information in a timely manner. One of the factors attributed to the spread of coronavirus is the fact that Chinese public health officials initially minimized the severity of the disease until it became impossible to ignore and had spread to other countries. It's also important to remember that an AI system is only as good as its data. The fact that Blue Dot system uses news reports in 65 different languages is actually really exciting in this respect, because it means that they might be capturing the ways that different cultures talk about health. This might be harder to do if you only relied on English language news. In fact, this is something that the natural language processing community, the part of AI that deals with understanding and interpreting language, has been struggling with recently, because a lot of the initial developments in the field were based around English, and we're finding that that both doesn't generalize well to other languages, and that there are actually a lot of interesting things that you can learn from looking at other languages than English. So hopefully Blue Dot system can serve as an example to future researchers and developers who are interested in tackling similar problems. What do you guys think? Do you think it's time for another go at predicting the upcoming flu season? Let me know in the comments. Also, some of you asked for videos that were a bit happier, that reflected kind of the good uses of AI, so hopefully this video will satisfy your needs. Otherwise, if you like this video, you can let me know by smashing that like button and subscribing to my channel. You can
Okay, and finally we will look at CT scans. Okay, sorry, this is actually not a video, but it's an article, so you can read about the CT scan situation, okay, how CT scans are used. Okay, so have a think about, you know, these are all the ways that AI has been trying to tackle you know, the COVID-19 virus. So we said, like, some companies were able to predict this outbreak quite early on. Like Blue Dot actually came out with the prediction that back in December that it was going to be an outbreak, and they scanned news reports in multiple languages. So because they were able to access certain, you know, reports in Chinese, I think that's why they were able to see, and they also looked at airline ticketing data. But what a more common way of dealing with this would have been through social media. Most companies would actually mine social media data, and they would see, like, what are the kind of things people are talking about. Are people, like, Googling for flu, or are they, you know, doing certain things, and then that would kind of alert them, and they kind of start to see. So a lot of companies are doing these kind of things, text mining. Okay, so in each scenario, which AI components could be used for the task outline? So you may want to pause this video for a while and have a think about which components that I spoke about just now might be used in all those systems you saw. And in, you know, in the next slide, we will discuss it. So you can pause now and play again when you're ready to have the discussion. Okay, so let's have the discussion now. Well, this is actually I just put this up very quickly, but it doesn't have to be limited to just these things. So when you look at the robots and drones that were used, okay, robots and drones will need to know how to navigate. So you saw that the robot was walking from room to room, right? So this navigation is actually a kind of planning process. It also can use something called reinforcement learning. Okay, reinforcement learning is quite an advanced topic which we will not cover, but I might actually mention what it is at some point. And they have to do, obviously they have to do computer vision, because they are looking at, you know, they are trying to see what is going on, so they're going to have to do computer vision. If robots are interacting with patients, then it's definitely doing some kind of speech processing. If, let's say, the patient is speaking to the robot and the robot has to react to that or something, then it would require speech processing. So the robot is actually a very complicated machine, and getting a robot, I mean, to work fully as a human being is hard, but in this case, they're quite specialized to do, you know, just distributing food to the patients. So instead of having a human being and putting that human being at risk to be infected, you use robots instead, which is quite a neat idea. And the same with the drones, right? That video of the drones going around, monitoring people and telling people, I think that's very useful as well. So it's putting people less at risks and using these kind of machines. I'm not sure how true those things are from those videos, but we can also kind of just claim, yes. Well, robots are also used in, you know, in nice areas like medical areas. They're very useful. So if you have someone who is sick and, you know, their condition as such is that they even need help to go to the restroom, and some people might be uncomfortable to have like a person holding them and going to the toilet and having them undress and so on. So they might feel more comfortable if it's actually a robot that is assisting them to the toilet, and that might actually be a bit more comfortable for them. Okay, and then the temperature screening system is something that the temperature screening system uses face detection and computer vision, because when people are passing by, it has to recognize that people are passing by. Okay, so the temperature screening system is using face detection. Obviously, it has to detect a movement right on the screen, and it has to detect which are the faces that are coming in, and then it's got to check the temperature of only those objects that are recognized as faces. So that is that's doing computer vision as well. Okay, and then for the outbreak prediction, so you're talking about mining news data, mining government reports. Those are all text processing. And a lot of companies are doing these kind of things, not just for outbreak prediction, but for many other purposes. So this is a big area of natural language processing, because all the information now is online, right? Even your conversations with your friend, your Twitter feeds, blogs, Facebook, LinkedIn, everything is out there, and it's public data. So why not just mine all this data and see what are the kind of things that people are interested in, or what are the kind of things that are, that is worth working on. And then the CT scan one, I didn't get a video for it, but maybe I will. That is obviously looking at images and then trying to detect lesions or areas that might be COVID-19 pneumonia in the lungs. So this is sort of, okay, this is very believable. With these robots and drones, I don't know how much of that is real, but this part is actually quite real, I can tell you. So what they do is the systems might be able to detect something, and then the human radiologist might look at that and verify that. So it's also a kind of area that is creating some debate, and we might look into that a bit further down the line, okay, to give you a better idea. So I guess this discussion can go on quite long, but I just thought it's a nice way to show you how AI is so prevalent in the world today, and even as something so recent, that's the COVID-19, AI is already there and trying to make a difference, and you can see how useful it is in tackling something serious like this. Just some thoughts in addition to that. Did an AI system actually beat doctors in warning the world about the COVID-19? So in some ways we can say yes, it has. But the thing is, an AI system can come up with all kinds of predictions if you think about it, right? And maybe they are just firing signals all the time. But they will always need to be followed up and justified by a human expert. Okay, so think about, think about this analogy. Think about a car alarm system. If any of you drive, you might see that it's just easily triggered, right? The alarm system is easily triggered, but oftentimes, you just ignore these. This might just be like a trigger that was not real. So the real triggers might just be one out of so many. So it's the same kind of idea. You don't want to take all of these predictions too seriously because AI systems are not that mature. Okay, a lot of things out there very much like at beta level. They're not really, so that's why in something like in the medical field, it's very sensitive still, but people can come out and say, hey, AI tried to warn you. AI was there telling you this virus is out and you didn't listen. So, there's a debate going on, can go on about that. But having said that, the truth is it's not that easy. So that's why we have to get AI and humans to work together. You really need the human expert to assess the situation and to make that call, is this really something that we should go with? also global agencies such as the WHO and the World Health WHO might be hampered from getting news due to bureaucratic hurdles and language barriers, because as we know, information in China is not easily available outside of China, and also because of the language. It's same in Korea. If you have information in Korean, it may not be easy to mine that information. So these are all like some barriers. That's why systems should be able to deal with not just one language but many language. And what we have seen from this exercise is image processing and natural language processing are two major areas of AI that is thriving today, and most rightly should so, because remember how we spoke about what were the things that humans can do easily, but it's hard for machines to do? These are very much the two areas that we're talking about. It's computer vision and natural language processing. But with deep learning and AI today, machines were able to tackle these two problems quite well, relatively well. And this is why AI is so successful today, and this is why there's so much money in AI, and everyone is, every government is putting billions of dollars into this area, because these two areas are just, data in terms of images and data in terms of text is just is everywhere and is crying out to be processed. And this is the two major things we have learned. So machines want to match humans' capabilities in processing images and languages. And machines are very good dealing with quantities, as we said, very good dealing with numbers. And this is where we can bring both these things together. Okay, so that is all I have for the first week. It was quite a long lecture. I hope you got a good introduction to AI. If you have any questions, feel free to email me. And I hope all of you keep yourselves safe and well, and I'll see you soon.